Linear networks are, like we mentioned before, the learning rule is really simple for those, so that's great. People like Satinder Singh and Ron Parr have gotten cool things to happen for things like cell phone channel allocation, and so that's pretty cool. You have to be really, really careful about what features you use, right? Because actually, I probably should have mentioned this before. The important thing about the features, I'm going to say that it's important that we find features that are both computationally efficient and value informative. And what I mean by that is computationally efficient. What would be an example of a feature that would be really, really great, but is not particularly computationally efficient?
The one that tells us what the proper action is? I don't know.
Or what the value is actually in
Oh,
this
yeah,
case.
sure.
Yeah, exactly so. So if there was a feature that actually encoded the value function, that would be great. That would be really good for learning. The thing is, we don't know how to get that feature efficiently. If we did, we wouldn't have to learn at all.
Right.
So we have to somehow get features that we can extract efficiently from the state. But again, that's really easy to do. We can just return the state as a feature.
Mm-hmm.
It's really important that it actually also be value informative, right? So that one feature actually gives you lots of information about what the predicted value ought to be. So somehow balancing these two things is often very tricky to get to work.
Right. So going back to our taxi example, if it turns out that knowing how far away the taxi is from some place or how far away a passenger is from some place, and you can compute that pretty easily, then you should do it because it's helpful. And your learning algorithm doesn't have to figure it out. And so that would be a good thing, right?
Yeah, so distance to passenger could be something that's both computationally efficient because you can just kind of pull it right out of the state representation, and probably value informative because it's actually very relevant to know, are we close to being able to pick up the passenger, or is the passenger quite distant and difficult to reach? So yeah, I think that's probably the kind of things that we would want. We probably should try that before we tell people that we think that's a great idea. But in general, these are the kind of properties that you're trying to balance.
Okay.
And I want to mention, because this is very hot right now, another example of using neural networks to learn value functions has been carried out recently by Google DeepMind, and they were using deep neural networks. Do you know what deep neural networks are?
Yeah, they're networks that are very profound.
Yes, they're poetic neural networks.
Mm-hmm.
No, they are neural networks that are neural networks, except some of them have, where instead of, say, 3 layers, they can have 10, 15. They can actually be quite substantially more sophisticated and complicated. And they often involve using things like convolutions to work well on visual kinds of inputs. So what Min et al. Did at Google DeepMind is they actually learned effective strategies for Atari video games, mapping the screen, the pixels on the screen, to joystick actions, which is really neat.
It is.
Right? I mean, so it's actually learning to play the game given very similar kind of input to what people get. And in fact, they were able to get it to learn very effectively to the point where you could argue that it was comparable to people on average.
At least on some games. But did it learn how to play thermonuclear war?
No, it learned that the winning move is not to play.
Oh, nice.
No, that's not true. That was a War Games reference. And in fact, it did not learn not to play. It was not given the option to learn not to play. It just had to play whatever it was given.
Grad school.
And we're back. No, it is true that on some of the games it was superhuman, and in other of the games it was way, way subhuman. And that was why I said you could argue on average that it was about human level.
Okay, but that's like arguing that on average, if I have my head in an oven and my feet in ice water, on average I'm comfortable.
Yes.